we look at oxidation states, and most of the oxidation states relating to oxyacids. Look here. Some elements have fixed oxidation states. Who are they? Elements of 1A: lithium, sodium, potassium, rubidium, cesium, francium. I repeat, lithium, sodium, potassium, rubidium, cesium, francium, which are called alkali metals. They always have a fixed oxidation state of +1. What I mean to tell you, in any compound they are always taken as +1. And elements of 2A: beryllium, magnesium, calcium, strontium, barium, radium, they always have +2. And fluorine always is -1, the oxidation state. So, with other elements, you can have any oxidation state. That is, for example, PCl3, the oxidation state of phosphorus is +3. PCl5, the oxidation state is +5. So, if I ask you what is the oxidation state of phosphorus, you can't say unless I mention what compound I am talking about. So, they have variable oxidation states. These set of elements, only these elements have rather fixed oxidation states. Okay? So, I repeat, 1A, 2A fluorine, and of course, there are one or two other elements, aluminium +3, zinc +2, one or two other elements are there. Don't make this list too long. It is enough if you know some elements have fixed oxidation states and some others don't. Most of the elements don't have fixed oxidation states. First point, fixed oxidation states. Whoever has fixed oxidation state. Second point, if oxygen gets 2-, oxygen -2, then it is called an oxide. I repeat, oxygen 2-, it is called oxide. O2 2-, 2 oxygens put together 2-, or 1 oxygen just 1-, O-, or an oxygen single bond. This is called oxygen single bond. This is called a peroxide. A substance containing oxygen single bond is called a peroxy compound. So, how to identify a peroxy compound? You should get the oxidation state of oxygen as -1. Each oxygen should get -1. 2 oxygens put together, they should get -2. And if two oxygens put together get minus or -1, or each oxygen -half, then it is called a superoxide. Superoxide, oxide, peroxide, superoxide. Let me look at some examples. What is the name of KO2? KO2. What would be the name of KO2? Is it potassium oxide or potassium peroxide or potassium superoxide? How will we go about the job? Potassium always has a fixed oxidation state which is +1. 2 oxygens together, they get -1. You know, the total should always be 0. If this is +1, both the oxygens should share -1 to give you a net 0. So, each oxygen you are getting a -half. So, oxygen in which you get -half is called a superoxide. Therefore, what is the name of KO2? KO2 is potassium superoxide. Potassium superoxide. Why do I call it a superoxide? Because oxygen is -half. Why is oxygen -half? Because potassium +1. Why is potassium +1? It is always +1, fixed. So, if you have an element with fixed oxidation state, it is very easy for you to deal with things. What about BaO2? You remember elements of 1A +1, 2A +2. What are the elements of 2A? Beryllium, magnesium, calcium, strontium, barium. Barium fixed +2. So, barium here is fixed +2 and 2 oxygens -2 and each oxygen -1. So, each oxygen -1. Here it is the sum of the oxygen states of both the oxygens, 2 oxygens minus 2, each oxygen minus 1. Therefore, this is called oxygen minus 1. It is called barium peroxide. What is important? Peroxide is important. Peroxide. How do I know it is a peroxide? Oxygen is minus 1. Why is oxygen minus 1? Two oxygens together are getting, collectively they are getting minus 2. Why are they getting minus 2? I have not given minus 2. I have not given this. They got minus 2. Why? Barium is plus 2. Why is barium plus 2? Fixed. In any compound, you can simply close your eyes and say barium, wherever it is, always plus 2. Of course, in a molecule. In a molecule, barium, or the role of barium is always loses 2 electrons in any molecule.